Hello everybody, this is Mr. Strager, and welcome to a Big Ideas lesson for Algebra 2. Today we're going to be talking about Lesson 1.3, and the reason why we're starting with Lesson 1.3 and not 1.1 is because Lesson 1.3 is something that we're basically reviewing, something we have done many times over, and something that I hope that we feel at least a little bit more comfortable with. It should be a nice introduction to the class. So, I would like you to turn to page number 15 in your student journals. You should see something like this. We're not going to start with the vocabulary. This will be a separate video for something very specific. I do want us to actually start down here, though, writing an equation of a line. So, we have learned in the past that there is something called a linear equation. Linear just means straight line. And the linear equation is y equals mx plus b. Now, there are a couple pieces I want us to remember about this equation. In this equation, while there are 4 variables here, 2 of them are going to be switched out with numbers in a full equation. The first one is this m. The m is called the slope of a line. We're going to talk a little bit more about the formula for the slope in a little bit, but recall that the slope of a line is how slanted it is, how stretched or shrunk it is. For instance, my pen right here. If we look at the slope this pen is making, it's sort of a shallow slope, right? If this was the ground, for instance, this wouldn't be a very steep hill. However, if my pen was like this, all of a sudden, this is a much more steep slope. The higher the number is for your slope, the more steep it gets. So this might be a slope of 5, whereas this might be a slope of maybe 1/3. The other variable that we like to talk about is this b value. The b value also has a name. It is called the Y-Intercept. When we look at a graph, the y-intercept is where the line crosses the y-axis. So if I was to give you, for instance, a graph that looks like this, the y-axis is this vertical line that my pen is covering here. The y-axis is the line that goes up and down. If your y-intercept is, say, 3, it means that you're going to be crossing right here at 3 on the y-axis. These things are extremely important when we talk about this equation, our linear equation. But what about the x and y? In general, when we write our answers, we want to keep the x and y empty, just keeping it as x and y. The reason being, we want to have the ability to plug in numbers to find new points. Let me give you a brief example here. Let's say I gave you the following equation. Y equals 2x plus 1. Right? This equation by itself is a finished equation. You could plug it into a graphing calculator and get a full line out of it. But if you don't have a graphing calculator, which hopefully we do for this class, we can still use this to find points. All we need to do is plug in values of x and see what values of y come out. So if I plugged in x values for, let's say, -2, -1, 0, 1, and 2, we can figure out what will come out of the equation, get a bunch of points, and connect those points to make a line. So if I plugged -2 in for x, for instance, all we're doing is changing out the x for a -2. This would be y equals 2 times, instead of x, we would put -2 plus 1. And we could solve. Of course, using PEMDAS, we know that 2 times -2 is -4, plus 1 is -3. So we know, hey, there is a point on this graph at -2, -3. And you can repeat this process for every point on this list if you wanted to. In fact, if you did, you would end up with the following coordinates. By plugging these points in on a graph and connecting them, you would get a straight line. That's why these equations are so important. Finding these equations, however, can be difficult because sometimes I will not give you all the information you need. Sometimes you will not have all the information needed. You might have to figure out what the line is. Let's start here, for instance. Let's say I give you a slope and a y-intercept. Remember that slope is m and y-intercept is b. Could you figure out the equation of a line from that? Let's take a look at the notes and see. So, on a separate sheet of paper, I want you to copy this down. Feel free to take some time to do this. Pause the video here and make sure you have a separate sheet of paper with the following copied. Hopefully you had a second to do it. Let's take a look. So, we're given a slope and a y-intercept. We want to write an equation for this. The good news is, we already know what the form of the equation takes. It's going to be y equals mx plus b, where m is the slope and b is the y-intercept. So really, all we're doing is, we're writing out y equals mx plus b with these two new values, where our m is 3/4 and our b is -2. So the equation just becomes y equals, instead of mx, we can write 3/4 x, and instead of b, we can write down -2, or just put a -2 here. This is the equation of that line. Now, let's talk about how to graph. As a reminder, in order to graph these lines, we always start with the y-intercept if we know it. Our y-intercept is at -2. That means there's going to be a dot on the y-axis at -2. This point could even be labeled as 0, -2. Anytime you have an x-coordinate of 0, that point is your y-intercept, so keep that in mind. It's a nice trick to save you some time. If the x value is 0, that is a y-intercept. From here, we just need to use our slope to figure out where the next points are. But how do we do that? Well, there's a little bit of a formula that can help us called the slope formula. Again, this is something that you have definitely seen at some point before. Slope is the same as rise over run. What does this mean? Your slope, your numeric slope that you get, should be a fraction or a whole number. It's basically a roadmap that tells you where to go next. From your starting point, the rise tells you how much up or down you have to go, and the run tells you how much side to side you need to go. So, let's take a look at ours. Our fraction was 3/4. Right? This is telling us that from our starting point, from this point right here, we need to rise by 3 and run by 4. Anytime you have a positive rise, that means we're going up. So this is telling you to go up 3. Anytime you have a positive run, it's telling you to go to the right. So this is telling us to go right 4. And our roadmap is complete. Our roadmap tells us we have to go up 3 and right 4. Let's take a look. Here's our starting point, 0, -2. We're supposed to go up 1, 2, 3 to here. And we're supposed to go to the right 4 and put another point. This new point is part of our line. And since we remember from geometry that we only need 2 points to make a line, we can go ahead and make the line right away. It's just going to be like so. This is the line of this equation. Again, You only need 2 points to make a line, so once you find one, your y-intercept for instance, you can use the slope to find another. I'm not always going to give you the slope and the y-intercept, however. It's not always going to be that way. Let's talk about what happens when I only give you the slope and a point. There are two ways to solve something like this. I'm going to show you the longer but more important way. Afterwards, I will show you the easier way. That's why I have it written down twice, so we can explore both ways. When you are given a slope and a point, there's an alternative formula we can use, something called point-slope form. In point-slope form, here is what we have. The formula goes y minus y1 equals m times x minus x1. We have a couple new variables here, right? Let's take a look. Y minus y1 equals m x minus x1. Well, m is familiar, right? We recognize m as our slope, and that's not going to change. That's still our slope, which is again rise over run. But this x1 and y1 are new. Recall that we want to keep y and x as they are, but everything else should be a number. So we need to turn x1 into a number and y1 into a number. x1 is the x of the point they give you. Remember that all points have an x and y coordinate. This is going to be the x of that point. y1 is going to be the y of that point. Y of point. Again, all we're doing is just plugging it into the equation. Let's take a look. So the example we gave is we have a slope of 2 and a point, -3, -5. Now, we should be very, very careful when we plug in. Remember that the equation is y minus y1 equals m times x minus x1. So when we plug these in, we can plug them in exactly as they are, right? Y minus, what's the y value of our point? It's -5. So we can plug in -5 here. Equals m. Well, m was our slope. That's just going to be the number 2 times x minus x1 is the x value of our point, which is -3. The thing about this, though, is that it doesn't look neat because we have all these minus negatives. To simplify, remember that minus and negative is the same as plus. So our final answer is y plus 5 equals 2 times x plus 3. There we go. This isn't very intuitive to graph. It's nice that we know it now, but it's not very intuitive to graph, even though we will learn some ways of graphing it in the future. We like to graph in y equals mx plus b form because then our b tells us where to start and our m tells us where to go next. If only there was some way to turn this into y equals mx plus b form. It turns out there is. Let me copy this on the back side of this sheet real quick. We'll take a look. If we have y plus 5 equals 2 times x plus 3, but we want to turn it into a form like this, y equals mx plus b, all we need to do is ask ourselves, what's different between these two, and how can we go from this to this? Well, think about it. There are two big differences here between the forms, and I wonder if you can pick out what they are. The most obvious one is that we have parentheses in this one, and this one doesn't have parentheses. Well, how do we get rid of parentheses? We recall that to get rid of parentheses, if there's a number outside of the parentheses, you can distribute into them. Distributing, remember, just means that we're multiplying into the parentheses. So the y plus 5 hasn't changed. The y plus 5 is staying here, but 2 times x is 2x, and 2 times 3 is 6. So this is what we've got. Y plus 5 equals 2x plus 6. From here, there's only one major difference. In the form we want, y is by itself. In this one, there's a plus 5. So how do we get rid of a plus 5? We recall that if we want to ever get rid of something, we do the opposite to it. We want to get rid of this plus 5, so the opposite of plus 5 is minus 5. These would cancel out. But whatever you do to one side of the equal sign, you must do to the other. So we also subtract 5 from this side. This will give us y by itself equals 2x. 6 minus 5 is 1. Y equals 2x plus 1 is the equation for that line. That means that y plus 5 equals 2 times x plus 3 is the same as y equals 2x plus 1. Let's graph y equals 2x plus 1. As a reminder, we could graph this, but we don't quite know how to yet. So we're going to instead graph this version, y equals 2x plus 1. Well, this tells us that our y-intercept is 1, so let's put a dot at 1. And the m tells us that our slope is 2. Huh. Well, we have a little bit of a problem here. Our m value is 2, but we're supposed to be able to put it into rise over run, right? But how can we turn it into rise over run if we only have one number? We recall that any whole number can be turned into a fraction very easily just by putting it over 1. Now we have a rise and a run. Our rise is 2, meaning going up 2. Our run is 1, meaning we go right 1. Up 2 and right 1 are the directions for this line. So, starting at our y-intercept, we go up 2 and right 1 and put another dot. That's the second point in our line. All we need to do from here is just connect them up. So we line up our straight edge. There we go, that looks about right. And we connect. That there is the line y equals 2x plus 1, the red. Now I did promise you that we would be learning a little bit of an easier way to do this, and we are. Here we have the same the same information, I should say. The slope is 2, the point is -3, -5. I'm going to put this up on the back, but remember, we want to eventually get to something that looks like this. The problem is, we're missing a couple pieces of information. Give me a second to write this out in the back, and I will show you what I mean. So again, our goal is to put it into y equals mx plus b form. Well, we have some information. We know that the slope is 2. So let's fill in what we do know. Y equals 2x plus b. And here's where we have a problem. It looks like we have no way of finding our b, our y-intercept. So do we just give up? Well, there is a little bit of a trick we can use. Remember that all points that are given are on the line. Meaning that if we had, like, for instance, a table over here with a whole bunch of values for x and y, maybe we have -4, -3, -2, -1, 0, 1, 2, whatever these values may be, we know that there is a pair that works. We know that pair is -3 and -5 because that's a point on the line that we're given. We know that -3, -5 works in our final equation. Well, hang on a second. If we know that those 2 points are valid, correct points, what would happen if we plugged them into the equation? Well, our y value would be -5, right? Our slope would be 2, because that was given, and the x value would be -3, but we still don't know this b value. What we do know now is that b is the only variable left. When you only have one variable left in an equation, it means the equation can be solved for that variable. Let's do it. To simplify this, let's see what can be simplified. 2 times -3 can be simplified as just a number, right? Because 2 times -3 is -6. So this is -5 equals -6 plus b. Well, how do we get rid of this -6 to get b by itself? We want to do the opposite, right? What's the opposite of -6? +6. -6 and +6 cancel out to make 0, so we know that that's going to give us just b over here. What's -5 plus 6? It's 1. Now look at what we have. We have a slope of 2, or an m of 2, and a b of 1. We have all we need for this equation. We can write it as y equals 2x plus 1. So that's an alternative way of doing this. An alternative way of finding an equation when you know a slope and a point is to plug everything in and solve for b. Of course, the line is going to look the exact same as before, so I'm not going to waste everybody's time with showing you how to do the slope again. It's the same one, where you start at 1, you go up to over 1. This is the same line as the red one up above. There is one more method to find the equation of a line, and it involves just knowing 2 points. In our notes on page 15, it says if you are given points x1, y1, and x2, y2, these are just labelings for 2 different points. It says we can use the slope formula to find m, then use point-slope form with either given point. What does this mean? Well, we have to remember the slope formula, and I gave you a little bit of a preview here. M is rise over run. But the full slope formula is a little bit longer. Here is the full slope formula. M does equal rise over run, but this isn't very mathematical. This is just a set of directions. Well, the rise is how much we go up by, right? For instance, if we started on floor 2 of a hotel and went up to floor 7, our rise would be 5 because we went up 5 floors. That means the rise is really just how much our y is changing. This triangle here is the Greek letter delta, means change. So our rise is our change in y. Our run here is how much left and right we went. So it's our change in x. Still not mathy enough for us, or at least not really usable yet, right? Well, the key is to find the difference between 2 y values or 2 x values, we just subtract them. That's what the difference is, right? The sum is adding things together, and the difference is subtracting them. So to find the difference between these x values and y values, we can just subtract them, like so. This is how, if you have 2 points, you can find the slope, by plugging it into this formula. y2 minus y1 over x2 minus x1. Let's take a look back at the paper and see if we can do just that. I've given you the points 15, -7, and 6, -1. Let's figure out what we can do here. The first thing I always recommend is labeling your points. Remember, we want a point number 1 and a point number 2, and it doesn't matter which is which. I'm going to choose to label, just to show you that it doesn't matter, the first one point number 2, and the second one point number 1. You could swap them around too, and it would still give you the same answer. Well, our formula, our long formula here, told us that m is rise over run, which is the same as the change in y over the change in x, which is the same as y2 minus y1 over x2 minus x1. y2 is just the y value of point number 2. Well, what's the y value in point number 2? We just labeled the first one point number 2. The y value is that second number, -7. So y2 is, I'm going to label it up here so we don't forget, -7. We also want to know the y value of point 1, or y1. Well, if we look at point number 1, our y value is -1. So we can put a -1 here. Next, we need x2 and x1. x2 is 15, because that's the x value of point number 2. That's x2. Forgot to label this one, I apologize. So x2 is 15. And what's x1? x1 is 6, because that's the x value of point number 1. Now we have everything together. All we need to do is do 2 quick subtraction problems and then simplify. What is 7 minus -1? Well, we recall that 2 negatives make a positive, so this is -7 plus 1, which is -6. What's 15 minus 6? That one's a little easier. It's 9. Can -6 over 9 be simplified as a fraction? It absolutely can. By dividing the top and bottom by the least common multiple, I apologize, the greatest common factor, we can divide both the top and bottom by 3. -6 divided by 3 is -2. 9 divided by 3 is 3. Our slope is -2/3. We now know our m. We've got most of the equation figured out. Y equals our m of -2 over 3 x plus b. But we run into the same problem as last time, which is that we don't know what b could be. But we know how to find it. Last time, we plugged in the point -3, -5 for x and y to solve for b. And we can do the same thing here. The best part is, we get to choose which point we want to use. Remember, all points that are given are on the line. So we can use either one of these, plug it into here, and find b. I recommend plugging in the one that looks easiest to you. So I'm going to plug in the 6, -1, just because I don't want to have to do any math with -7s and 15s. So our y was -1, so we plug it in for y. That equals our slope of -2/3. But instead of x, we're putting down the x value of 6 plus b. Let's simplify. What's -2/3 times 6? Remember, this is basically the same as saying, what's -2 times 6 divided by 3? It's -4. So, -1 equals -4 plus b. Well, what do we do from here? We want to get b by itself, so we can add 4 to both sides. These ones cancel out, and what's -1 plus 4? It's 3. Our b value is 3. We know our m of -2/3 and our b of 3, so we know our full equation. Y equals -2/3 x plus 3. All we have to do now is graph. Our y-intercept is +3, so we put it at 3. Our rise is -2, and our run is +3. When you have a negative rise, that means to go down. So it's asking us to go down 2 and write 3. And there's a second point. So finally, all we have to do to make our line is connect them up. And this is our line. Y equals negative 2/3 x plus 3 is the red line. All right. Thank you so much, everybody. This concludes lesson 1.3. Next time, we're going to backtrack, and the time after that, we're going to finish 1.3 with a little something called a line of best fit. Until then, have a fantastic rest of your day.